Kumar, can you hear me?
Sorry, sir.
Can you
Yes,
hear me?
yes, sir. Yes, sir.
Okay, so I request you to mute yourself.
Okay, thank you.
I will wait for a few minutes for other students to join, and then we will start at around 7:10 or 12.
Okay, sir. Okay, thank you.
Hello everyone, a very good evening to all. Myself, Vivekananda Naik. I am a PhD research scholar in the Department of Energy Science and Engineering, IIT Delhi. So I welcome you all once again for this third interaction session based on the NPTEL course Solid State Physics, which is being taught this July 2024 session. Its course code NOC 24 PH 43. So in this interaction session, we will be solving a few sample problems that will be based on the week 3 lectures of the course content, and it will mainly cover the crystal structure part and some elementary part of X-ray diffraction. So let's start with the first question of our day. Question number one. It says in magnesium oxide, the Mg2 plus ion and oxygen 2 minus ion with with radii 0.78 angstrom and 1.23 angstrom respectively. Magnesium oxide having FCC structure and its per unit cell contains 4 number of magnesium oxide units. Calculate the density of magnesium oxide given Avogadro's number Na is 6.023 into 10 to the power 23. Atomic weight of magnesium is 24.3 gram per mole and that of oxygen is 16 gram per mole. And magnesium oxide has the same structure as NaCl. The options are option A 3.61 gram per cubic centimeter, option B 4.21 gram per cubic centimeter, option C 9.27 gram per cubic centimeter, and option D 9.87 gram per cubic centimeter. So this question is given. We are talking about magnesium oxide, and in magnesium oxide, how the magnesium oxide is formed? It is there is an ionic bond between magnesium and oxygen. So magnesium has given its 2 electrons, so it is magnesium 2 plus, and oxygen has captured those 2 electrons. So an ionic bond is formed between them, and due to the force of interaction, that is attraction as well as repulsion, because attraction will take place between their uh, charges and repulsion will take place between the electron clouds. So they undergo a particular type of crystallization structure, and that is FCC. So here it is mentioned magnesium oxide has FCC structure. So magnesium oxide has FCC structure, and in the question it is also mentioned magnesium oxide has the same structure as NaCl. So in case of NaCl also, sodium acquires positive charge and chlorine acquires negative charge, and they are ionically bonded with some particular type of FCC structure. And in this question, also it is mentioned that magnesium oxide has FCC structure as well as per unit cell it contains 4 number of magnesium oxide units. And we need to calculate the density of magnesium oxide where the given values are Avogadro's number is given because we know here the atomic weight is given per mole and 1 mole contains Avogadro's number of molecules. So we need the multiplication factor or division factor. And the atomic, since we are calculating the density, we need the atomic mass we need. So here mass is given, mass of magnesium and mass of oxygen is given. And we need to calculate the density of magnesium oxide. So I'll give you a few minutes to try this question and then I will discuss. So Sunil Kumar, did you try this question?
I tried, sir, but not came.
Sorry, once again, I can't hear you properly.
I tried, but not get it.
Okay, so I will discuss.
Okay.
So in this question, it is given magnesium oxide has FCC structure, and for FCC we know the number of atoms per unit cell is 4. And in the last interaction session, it also discussed. So in FCC, the structure is like, suppose FCC means face center cubic. So it is a cubical structure, and there are atoms at each corner of the cube. So there are 8 atoms because one cube has 8 corners, and each one atom at the center of the face. So it has 6 faces. So one is here, one is here, one is here, one is here, one is here in the front face, and one is here in the back face. So there are all total 14 atoms, out of which there are 8 atoms that are present at the corner, and the remaining 6 are present at the surface or the face of the cube. So if you see, the total contribution from these 8 atoms will be 1, because this one atom contributes 1 to 8 crystals. So if you want to see the whole contribution, so there are 4 crystals here and another 4 above it. So in a three dimensional structure, we need total. So this one atom contributes to 8 crystals. So this one atom contributes 1/8 to a single crystal. So the blue ones contribute 1/8. So there are total 8 numbers. So 8 into 1/8. The total contribution will be 1. And then if we talk about these atoms or these lattice points, they contribute 1/2, because if you see, suppose this is a face. If you add another face and the atom is present here, it will be completely contributed. So each atom, this red one, they contribute half to a single crystal. So there are 6 number of atoms. So 6 into half, it will be 3. So 3 plus 1, total 4. So there are 4 number of atoms per unit cell. So in magnesium oxide, it has FCC structure. That means the magnesium 2 plus, which is present, magnesium 2 plus atom, it has an FCC structure within itself, and the oxygen 2 minus or oxide atom, it also has an FCC structure on itself. So there are 2 FCC structures, and they are displaced by one half of the body diagonal, and they form the magnesium oxide molecule. So if you talk about magnesium oxide molecule, so how it will look like? So it will be similar to that of NaCl. So I'll be drawing the NaCl. So if same, you just replace Na plus by magnesium 2 plus and Cl by oxygen 2 minus, you will get the same structure. So if you draw the NaCl structure, then NaCl has FCC structure. So it will be like this. So there are, I told you there are 2 FCCs. So there are 2 FCCs. So we will be drawing like this. It will be somewhat like this. So if you see, So these will be the positions of Na. So this stands for Na plus, and if we draw, then this will be for Cl minus. I forgot to draw another line here. So one line will be like this, and one will be like this. So it will be somewhat like this. So if you see here, in case of NaCl structure, its Bravais lattice is a phase center cubic with a basis of one NaCl and one sodium and one chlorine ion separated by one half of the body diagonal of a unit cell. So if you talk about the coordinates of those atoms, so there are uh, just I told you that there are four atoms per unit cell. So in case of NaCl, there are four Na plus and four Cl minus. So if we talk about their positions, so for Na, the coordinates will be half, 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 0, 0, half, 0, half, 0, and half, 0, 0. Similarly, for Cl, it will be 0, 0, 0, 0, half, 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 0, half, and sorry, it will be half, half, 0. So there are four. So in each unit cell of sodium chloride, there are four sodium and four sodium ions and four chloride ions. So similarly, in this magnesium oxide crystal also, there will be four magnesium and four oxide ions. And we know, if we talk about the density, there is a formula. The formula of the density is mass by volume. It is N into mass divided by volume V, and there will be Avogadro's number. So here N is 4 because there are four atoms of magnesium as well as oxide, and V is volume, and the volume will be AQ. And what is A? A is the lattice parameter, that is the side of the cube. So if we talk about the side of the cube, suppose this is A, then it will contain, suppose let it, I will draw it like linearly. So suppose this is A, total this is A. So one atom is present here, another is here, and another is in between them. So this is one radius, this is one radius, and this is, suppose this is Mg, and this is O, and this is Mg. So there will be two radius of Mg and two radius of oxygen. So if you talk about the lattice parameter, the lattice parameter A will be 2 into radius of magnesium plus radius of oxygen. And the value is also given. So it is 2 into 0. What is the value? It is 0.78 Armstrong and 1.23 Armstrong. So it is 0.78 plus 1.23. So total it will be 4.20 Armstrong. And N is 4, and if we calculate M is mass of MgO. So mass of MgO will be mass of magnesium and mass of oxide. So it is 24.3 plus 16. So 24.3 plus 16 gram per mole. So since it is per mole, that's why we are dividing this by a number, Avogadro's number, that is 6.023 10 to the power 23. So if we calculate the density, so let me add another slide. So the formula is density rho is N M divided by V Na. So N is 4, M is 16 plus 24.3, 16 plus 24.3 divided by this volume is A cube. A cube means it is 4.2 Armstrong cube. And since here we need to find the answer because the options are in gram per cubic centimeter. So here we need to convert Armstrong into centimeter. So if you convert Armstrong in centimeter, it will be 4.2 into 10 to the power minus 8 cube. Then Avogadro's number 6.023 into 10 to the power 23. So if you calculate, so the unit will be gram per cubic centimeter. So because this is in gram per mole, this is per mole, then per mole will get cancelled out. Then it is centimeter cube, so it will be gram per centimeter cube, and the value will be 3.61 gram per cubic centimeter. So if you see the options, option A is 3.61. So the correct option is option A. So is this clear to you?
Yes, sir.
Okay, so
Okay, no problem.
uh, so in the question it was given that we need to in the question it was asked to find out the density of magnesium oxide, where magnesium oxide has an FCC structure. So since it is an FCC structure, it contains 4 magnesium and 4 oxygen atoms. So we will be calculating the mass, and then we will calculate the lattice parameter. So for lattice parameter, as we discussed, there will be 2 radius of magnesium and 2 radius of oxygen. So this is the lattice parameter. And after calculating the lattice parameter, we know n is equal to 4 for FCC structure, and the volume is A cube. So if you put all these values, you will get the density of magnesium oxide is 3.61 gram per cubic centimeter. So we'll proceed to the next question. The question says
Okay.
aluminum has an FCC structure. Its density is 2700 kg per meter cube. Calculate the unit cell dimension. The atomic weight of aluminum is 26.98 gram per mole, and the Avogadro's number is 6.023 and 10 to the power 23. So it is pretty much similar to the previous question, but in previous question we calculated the lattice parameter, and then we calculate the density. But here the density is given, and we need to find out the unit cell dimension, that is the lattice parameter. So we will use the same formula. So the formula will be density rho equals to N A is the mass number or mass by V Na. So V is the volume, and from this volume we will calculate the unit cell dimension, and N we know, A also we know, and Avogadro's number is also given. So I will give you a few minutes to try this question and calculate what will be the correct answer, and after that I will discuss. So did you calculate?
It is 6.15 angstrom minutes.
Sorry.
6.15 angstrom minutes.
So how did you calculate that? So what will be the value of n?
I took atomic means V is the dimensions I took unit cell dimension.
Sorry, once again.
I took V is the unit cell dimensions.
Then
So
what
V
did you
okay.
take the value of n?
Uh,
What value of n did you take?
n is small n is equal to 4 FCC structure.
Yes, n will be
Next
4 for FCC structure. Then
atomic weight of 26.98 gram per mole.
26.98 gram per mole. Yes, then
Then this Avogadro number is given 6.023 in 10 to 23 and density 2700. Rho means 2700 kg per meter cubed. So I have to
yes.
change into the grams. So then
So
we
if you
get V
change
value
it, it will be how much?
in the gram per centimeter cubed.
So it will
Actually,
be
so, uh, 10 cubed by 10 whole cube is equal to 10 power 3 into 10 power minus 6 to 10 power minus 3. It will be 2.7 gram per centimeter cubed.
yes. So if you put all the values, what will be the answer?
Uh, that time I got nearly actually 6.6 I got nearly.
No, I think
6.6.
you have calculated it wrong. The correct answer will be option D, that is 4.05. So, like you said, so FCC n is 4 and A is the mass
Yeah.
that is already given. It is 26.98 gram per mole. Avogadro's number is also given 6.023 into 10 to the power 23. Then V is AQ. So here we need to find out the
Yeah.
value of A. So what will the value of A? So how we
Okay.
will
That is a whole
calculate?
power 1 by 3 I have to consider.
Sorry?
From this equation we get V value. After then we have to calculate A value. Yes, sir?
Yes, yes. So what we will do? So rho is again density is
Okay.
given. It is 2700 kg per meter cube. That will give you 22.7 gram per cubic centimeter because 1 kg is 10 to the power 3 gram and 1 meter is 10 to the power minus 2 centimeter. So 10 to the power 2 centimeter. So if you convert meter to centimeter, it will be 10 to the power 2. So it will be 10 to the power 6. So 10 to the power 3, 10 to the power 6 will get cancelled and it will give 10 to the power minus 3. So 27 into 10 to the power minus 3, it will be 2.7. So it will be 2.7 gram per centimeter cube. So if you put the values, so it will be 2.7 equals to 4 into 26.98 divided by A cube into the Avogadro's number 6.023 into 10 to the power 23. So A cube will be 4 into 26.98 divided by 2.7 into 6.023 into 10 to the power 23. So if you calculate its cube root, it will give you 4.048 into 10 to the power minus 8 centimeter. And we know minus
Yes.
8 centimeter is 1 angstrom. So the answer will be, so it is 0.048. We can approximately take it as 0.4.05. So 4.05 angstrom will be the lattice
Okay.
parameter. This is the correct answer. And if you see the options, it is option D.
Yes,
I
sir.
hope this is clear to you.
I understood, sir. Actually, I found out the value as a V value, actually.
Okay,
After then, I
okay.
have to calculate A.
Yes. So since it is a cubic structure, so the volume of the cube is
Yeah.
AQ. So you need to find out A. So the
Yeah.
because in the question it is say calculate the unit cell dimension. Unit cell dimension means the side of the cube. So we will calculate the value of A.
Oh,
So okay, I will.
okay.
So we will move to
Yeah.
the next question. So the question says iron changes from body center cubic to face center cubic at 910 Kelvin. At this temperature, the atomic radii of iron atoms in the two structures are 1.258 Armstrong and 1.292 Armstrong respectively. What is the percent volume? What is the percent volume change during this structural change? That is percentage volume means it is also mentioned in the bracket associated by per atom in the corresponding unit cell of the two structures. So here we will find the volume per atom. So that was volume, but here it will it is asked that to find out the volume change, that is the change in volume per atom. So if we divide the total volume by the number of atoms in the unit cell, we will get the volume per atom. So in the question says, so the options are minus 0.46%, minus 0.56%, minus 0.66%, or minus 0.76%. So in the question is given, we know Fe is iron, it goes from BCC to FCC. So in BCC, so it goes from BCC to FCC as 910 degree centigrade. So in BC2, we know the number of atoms per unit cell is 2, but in FCC, the number of atoms per unit cell is 4. So since the number of atoms per unit cell is changing, and also the atomic radius is changing. So the atomic radius, since it is changing, so there will be change in the volume. Since the radius is changing, there will be change in the volume, and since the volume is changing, the uh, volume per unit cell, the volume per atom will change because the number of atoms is also different for FCC and BCC. So in this question, we need to calculate that change in volume. So I will give you a few minutes to try this question and then I will discuss.
Sir, if you don't mind, please tell me, sir.
Sorry.
Or please explain this one.
Okay, so
Actually, I don't
yes,
have
so
calculator. I don't have, so that it's long.
okay, so we'll discuss the question. So
Yes, sir.
you see here we need to calculate the change in volume for the per atom. So if you talk about body center cubic that I already told, in case of body center cubic there are
Two
two
atoms are
atoms per
present
unit
here.
cell,
Yes.
but in case of phase center cubic there are four atoms per unit cell. So in order to find
Yeah.
volume, we need to find, so volume means volume will be same. I mean the expression for volume will be same. For BCC the volume is also AQ, and for FCC the volume is also AQ. But here A will be different because R is different, and the relationship between lattice parameter and the radius of atom is also different for body center cubic and phase center cubic. Because if you see for body center cubic, 4R is given as root 3A, but for phase center cubic, 4R is equals to root 2A.
Okay.
Because if you see the
Yeah.
structure, in case of body center cubic, like here I draw you na here. So where did I? So here, here in the previous case, if you see here, it was one side, so it was A only. But in case of body center cubic, the same structure lies at the body diagonal. So in case of body center cubic, this 4R will become root 3A because the length of the body diagonal for a cube is root 3A. And similarly, for phase diagonal, the length of the phase diagonal will be root 2A, so 4R will be root 2A. So if you see, suppose we will first calculate BCC. So in case of BCC, A is 4R, suppose B means BCC by root 3, and also N is equals to 2 because in body center cubic there is 2. So if you calculate the volume in BCC per unit cell, it will be A cube by 2. This is volume per atom in BCC. So A cube means 4RB divided by root 3 cube by 2. So if you calculate, it will be 6.16 RB cube. So this is the volume per atom for body centered cubic. And if you calculate phase center cubic, A is 4RF by root 2 and N is 4. So for phase center cubic, it will be A cube by 4, which is the volume per atom. So volume is A cube and number of atoms is 4. Per atom is by 4. And it will give you 4 RF divided by root 2 cube divided by 4. So it will give 4 root 2 divided by 4. So it will be give 5.66 RF cube. So one is 6.16 RB cube and this is 5.66 RF cube. And if you calculate the percentage, so initially it was 6.16, but it changed from 6.16 to 5.66. So the percentage change will be 5.66 final minus initial 6 6.16 RF cube. It is sorry RF cube is RB cube divided by 6.16 RB cube into 100. So if you calculate, it will be 5.66, and RF for phase center cubic the value was 1.292 angstrom. So it will be 1.292 Q minus 6.16 into 1.258 Q divided by 6.16 into 1.258 cube. So here we are not converting Armstrong to centimeter or meter because it is, since it is a ratio, so both the factors will get cancelled out.
Cancelled.
So if you calculate it, the correct answer will be minus 0.46 because if 5 it is minus 0.46. So because the change, the volume change per atom is reduced if the structure changes from body center cubic to face center cubic. So that's why there is a change in the volume per atom. So the correct option will be option A, that is minus 0.46. So this is also so that's why if you talk about the packing fraction and compare the structure of body center cubic and face center cubic, you will find out that the packing fraction is more for face center cubic than body center cubic, and that also represents that the atoms are closely packed. And since the atoms are closely packed, the volume will be reduced. That's why we are finding negative percentage change in volume. So is this clear to you?
Yeah, yeah. So
Okay,
that
so
means
we'll go to yes.
actually basically it is a body centered cubic structure, sir. So that its volume reduced compared with the FCC.
No, body center cubic has more volume in comparison to number per atom. Because if you see, there are 4 number of atoms in face center cubic and
Yeah.
2 number of atoms in body center cubic. Even if the radius is same for body center cubic and face center cubic, since the number of atoms is twice, so the volume per atom will be reduced to half. But since here the size also different, it is 1.292 and 1.258. The radius is also different. That's why we are not getting we are getting 0.46%. Otherwise, we could have got some other values.
Yeah. Okay.
Okay, so
Okay.
we'll go to the next question. The question says, calculate the density of cesium chloride. This crystal has the radius of the ions. Cesium plus is 1.65 Armstrong. Chlorine minus
The
is
slide was
1.81 Armstrong. Sorry?
slide one slide not visible. Okay, sir.
Now it is visible.
Yeah, yeah, sir.
Okay, so uh, we will calculate the density of cesium chloride crystal with the radius of cesium is 1.65 Armstrong and radius of chloride is 1.81 Armstrong. We will consider the lattice parameter of cesium crystal is 2 radius of cesium plus radius of chlorine divided by root 3, and it's having simple cubic structure. So we will assume it is simple cubic, and the atomic weight of cesium is given. It is 132.905 gram per mole, and for chlorine is 35.453 gram per mole. And the Avogadro's number is 6.023 10 to the 23. The options are option A 8,232 kg per meter cube, 6,872, 4,384, or 2,182. So these are the 4 options, and we need to find out the density of cesium chloride. So we will
Density.
use the same formula again, but here we will take a
In,
few things that is different from the previous questions. So I will
means
give you
n is equal to
examples
1,
how it
right,
is.
sir?
Yes.
Okay. Okay, sir. Here small n is equal to number of atoms per unit cell is equal to 1.
Yes. So
Because
since
simple
here
cube
it is
is
given,
yes.
it is having a simple cubic structure. So we will take for simple cubic
N is equal to 1.
number of atoms per unit cell is 1. But for simple cubic, the relation is not this. That's why the relation is given explicitly. So you will take this value of A and we will take n equal to 1 because it has been mentioned that we need to consider the structure as simple cubic. If it would have been given that, consider the structure as, so if you see this relation A equals to 2 RCS plus RCL divided by root 3. So from this relation, you can easily say, since it is root 3A, so this corresponds to body centered cubic structure. But in this question, it is mentioned take simple cubic structure. That's why you will take simple cubic structure. But actually, this relation corresponds to body centered cubic structure.
Oh, yeah.
Did you
Actually,
get?
A is equal to 2R, sir. A is equal to 2R for
Sorry?
simple cubic. A is equal to 2R actually.
Yes, for simple cubic, A will be 2R, because if you see the
2R.
simple cubic structure, if you see the simple cubic structure, it is the one side, so there will be two atoms arranged like this. This is one R,
Yeah.
this is another R. So this is for simple cubic, but actually the cesium chloride is not simple cubic structure. It is the corresponding.
BC.
If you see the, so it is the, what, there is one cesium atom and one chloride atom. So we have to take this relation of A. Because why this is given? Here n equal to 1 is given because if you see, cesium chloride has simple cubic structure, but in center it has, in one corner it has cesium and in other corners it has chlorine. So that's why we will take one cesium and one chlorine. So there are two atoms. So simply, if you see body center cubic also, there are two atoms per unit cell.
Yeah.
So there, so like this, it, and there is one chlorine. So this is one chlorine, then this is cesium, 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 cesium. That's why the relation is like this. So if we calculate it, the relation is density rho equals to n m divided by Avogadro's number A and volume V. So we will take n equals to 1. M is also given. So M is 132.905, 35.453. So M is also given. Then V is A cube because it is simple cubic, and then Avogadro's number is also given. So if you put those values, it will be 1 into mass is 132.905 plus 35.453 divided by 6.023 into 10 to the power 23 into the size we need to find out. Sorry. So A is also given. So if you calculate A will be 2 into R cesium. R cesium is 1.65 plus chloride is 1.81 divided by root 3 Angstrom. So if you calculate it, you will get
Okay.
3.995 Angstrom. So this 3.995 means it is 3.995 into 10 to the power minus 8 cube. So if you calculate it, you will get 4.384 gram per cubic centimeter. And if you convert it to kg, simply like in the previous question, we had divided it by 1000. We will multiply 1000 in order to convert it from gram per cubic centimeter to gram per into kg per meter cube. So it will be
Okay.
4384 kg per meter cube. So if you
Interesting.
see the options, option C 4384 kg per meter cube is the correct option. So is this clear to
Okay.
you?
Yeah, I understood.
So
But even though it is given the simple cubic, based on the problem only, you have to do the problem. Yes, sir? Or A is equal
yes,
to, actually,
no,
that is
simple
for
cubic.
BCC structure.
This is the lattice is simple cubic, but if you see in case of simple cubic structure, like we just mentioned, na, in case of sodium chloride, sodium has FCC, chlorine has FCC, and the whole structure is FCC. But in case of cesium
Yeah.
chloride, the cesium chloride, it is the space lattice is simple cubic, but at the center there is chlorine, and at the corners there is cesium. So that's why we will
Okay.
be taking. So in simple cubic, what happens?
See.
In simple cubic, we have one atom, one atoms or one atom per unit cell. But since it is a molecule, we'll be having two atoms per unit cell, because one will be present at the center. That is, so if you see, like in the I just mentioned that in case of sodium chloride, we had mentioned four coordinates, that is 0, 0, 0. Sorry, for
For
sodium it was
chlorine,
half half.
for chlorine 000.
For chlorine it was 0, 0, 0. So there are four and there are four. So similarly for
Yes,
cesium
sir.
chloride, if you see, for cesium it will be 0, 0, 0. So the cesium is present at one corner or at the origin, and then chlorine is present at half, half, half. That is at
Half,
the
half, half.
center of the body diagonal. That's why we are taking. So this, since this is this half, half, half will come only when the chlorine is present at the center of the body diagonal. That's why this length will be root 3a, and there will be 4r. So 4r
Yeah.
means 2r corresponds to cesium and 2r corresponds to chlorine. That's why the relationship is given 2r cesium plus r chlorine divided by root 3. So did you
Okay.
get that?
Yes, sir. Yeah.
So we'll go to the fifth question. The question says, in cubic zinc sulfide, the radius of zinc and sulfide atoms are 0.43 Armstrong and 1.74 Armstrong
Uh,
respectively. Yes.
okay, sir. Now it comes. Slide, it's coming
Okay.
slowly,
So
sir.
there might be some network issues, I guess. So if
Yeah.
you see, so now you can see the slide.
Yes, sir.
Okay. So
Now it's
if you
okay.
see, the question says, in a cubic zinc sulfide, the radius of zinc and sulfide atoms are, for zinc it is 0.83 Armstrong, and for sulfide it is 1.74 Armstrong. And we need to find out the lattice parameter A using the following relation: A equals to 4 radius of zinc plus radius of sulfide divided by root 3. So it is very straightforward question. If you see, we simply need to put the values and get the answer. There is no other hidden things here. So these are the options. Option A is 5.935 Armstrong. Option B is 6.125 Armstrong. Option C is 6.527 Armstrong, and option D is 6.725 Armstrong. So since this is very straightforward question, I'll give you very few minutes to try this question, and then we'll proceed to the next question.
Sir, in this one, molecular weight I have to consider, sir.
So did you calculate?
It is a 5.935 angstrom. Initial
Yes.
one.
So the correct
Yeah.
option will be 5.935 angstrom. So it is pretty simple. So if you see A is 4 R zinc plus R sodium sulfide divided by root 3. It is 4 by root 3, 0.83 plus 1.74, and it is 5.935 Armstrong. So the correct option is option A. So and if you talk about zinc sulfide structure, it is also called as the zinc blende structure, and it is pretty much identical to diamond structure. But if you compare it between diamond
Sorry,
structure and
sir.
so it has two axis structures and they have different atoms and they are displaced by 1/4 of body diagonals. But in diamond structure, what happens? In diamond structure, in one unit cell, there are
Hello, sir.
18 carbon atoms. So 4 are present at 1/4 or 1/4, and other 14 are present in a particular position. But since so if you compare the structure of sodium it was two axis structures and they were separate. They were displaced by 1/2 of the body diagonal. But here they are separated by 1/4 of the body diagonal. So zinc has also one. So zinc it is one structure and sulfide it is one structure and it is displaced by 1/4 of the body diagonal. That is 1/4. So we'll go to the next question. The question number 6. The question says if the lattice parameter of silicon is 5.43 Armstrong and the mass of silicon atom is 28.08 into 1.6 into 10 to the power minus 27 kg, then calculate the density of silicon in kg per meter cube and consider silicon having diamond cubic crystal structure. So it does discuss about diamond cubic crystal structure and the options are option A 2329 kg per meter cube. Option B 1115 kg per meter cube. Option C 3445 kg per meter cube. And option D 1673 kg per meter cube. So these are the four options, and we will calculate the density of silicon in kg per meter cube.
Sir, here diamond has a FCC structure, sir.
So then diamond has a particular structure that's why it is called as diamond cubic structure. So if we talk about the structure of diamond, so there are two types of atoms. Like as I already mentioned in the previous question, in case of zinc sulfide, why this is 4? Because there are four atoms. Sorry, there are four atoms along a particular line. So there are yes, so there are four atoms along a particular line. That's why it is 4 into R zinc plus R sodium. So how this is possible? This is possible only when the face center cubic. There are two face center cubic structures, and they are displaced by 1/4 along the body diagonal. Now, if you see the structures, suppose there are two face center cubic structures. Suppose this corresponds to one. Nana, suppose this is the body diagonal. So one is present here, one is present here, one is present here, one is present here. Since it is a face center cubic, so one will be present here because it is a face. But if you see, in case of diamond cubic, what happens? There is another piece, like in sodium, one has FCC, another is has also FCC, and they are displaced by 1/2 of the body diagonal. Here, the two structures are displaced by 1/4 of the body diagonal. So another will be starting from here. So one will be, another structure will be like this. So one will be present here, then there will be at the middle. So one will be present here, one will be present here, one will be present here, and another will be present here, another will be present here, here, here. So there are four atoms of different. So if you see, these are the displaced positions. So this is 3/4. This is displaced by 3/4. This is 1/4, and this is 1/4. So this is the 4 which is completely inside. So this is the 4, and other 4 are these 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 1, and these 4 will contribute to 1, and these 4 will contribute to 2. How? So this is present completely inside the face, so it will contribute 1. But these are present at the corner. So corner means they will contribute to another 4 crystals. 1, 2, 3, 4. So in order to enclose all these atoms, we need 4 crystals. So corresponding to one crystal, their contribution is 1/4. So they will give 1/4 contribution. So since there are four such crystals, four such positions, they'll contribute one. Sorry, this one. So this one corresponds to the center one. This one corresponds to the corner ones. And since there are four present here also, so if you suppose this is present at the face, so one crystal is here, another crystal is here. So this is one crystal, this is two crystal. So it will be completely acquired. So corresponding to one crystal, the contribution is half. So this is half also, this is half, this is half, this is half. So this 4 into half is 2. And these 4 are completely lying inside. So this will be giving 4. So it is 4 plus 1 plus 1 plus 2. So total will be 8 atoms per unit cell.
Yeah.
So if you calculate the density, how will calculate the density? We know it is rho N A
NM
divided by
by
V N A.
Avogadro number.
So here, if you see the question
Small
here,
n.
Avogadro's number is not given. Why?
Yeah. Atomic rate
Can
is
you
not given.
think why it is not given?
Because
Because if you see
lattice
here, the mass
parameter
of silicon.
lattice parameter.
No, because here the mass of silicon is not given in terms of gram per mole or kg per mole. Here the mass of one atom of silicon is given. So that is in kg. So that's why we don't need the conversion factor. Understand? Because suppose in the previous question that we discussed, not here, here the mass of cesium and chlorine were given 132.905 gram per mole. Gram per mole means the mass of cesium atom is 132.905 gram. That is 1 mole of cesium atom. 1 mole means Avogadro's number of atoms. But since here only direct mass of the silicon is given, and the mass of silicon is given in kg, so it is 1. We know 1 mu is 1.66 into 10 to the minus 27 kg. So the mass is given in terms of mu, that is atomic mass unit. That's why we don't need to convert it to per mole, and that's why the conversion factor is not present here. So if you see, we'll not need this. We'll simply calculate n m by v. Here this is mass and this is volume. So n is 8. We just discussed how n will be 8. Then mass is 28.08 into 1.66 into 10 to the power minus 27 divided by 5.43 into 10 to the power minus 10 cube. Because volume, the lattice parameter is given 5.43 angstrom. So we directly put the lattice parameter, that is A, and since it is a cubic means A cube is the volume. And if you calculate, it will give 2329 kg per meter cube. So we convert it into meter because Armstrong is 10 to the minus 10 meter. So this is converted into meter and this is given in kg. It is kg per meter cube. So the density of silicon is kg per meter cube, and the correct option is 2329 kg per meter cube. So the correct option is option A. So is this clear to you?
Okay, sir. Just the arrangement of atoms in the structure. Once again, I want in the diamond
Sorry?
structure. The arrangement of atoms that in the diamond structure. Please explain once again, sir.
Okay, so in case of diamond structure, what happens? There are two
Yeah.
structures. Like in case of simple cubic structure, we discussed. So in case of NaCl, sodium chloride structure, sodium has a structure of FCC. So sodium has a lattice of FCC and chlorine has a lattice of FCC, and they are displaced by one half of the body diagonal. That's why if you see here, we just displaced half. So this is one. So if you see, so this is one atom, and then it is displaced by half. You understood?
Yes,
So this is
I understood.
one, but here in the diamond crystal, it is displaced by 1/4 of the body diagonal. That's why this is the structure. So from this to this is 1/4 of body diagonal. So this is 1/4, this is 1/4, this is 1/4, and this is 1/4. So since it is displaced by 1/4, so these four atoms that are present, they are already inside. So that's why I draw you a particular phase. So in this particular phase, these four atoms, those are filled. These are completely contributing to the unit cell. Is not it? If you see, these are completely enclosed. So that's why they are contributing totally. So this four comes from this four. And then those are corner. So those atoms that are present at the corner, they will contribute to four. Since it is a planar structure, we are only considering the two-dimensional case. So it will contribute to the four crystals. So this so four crystals. If you draw four crystals, suppose this is present at the corner. So and if you draw here 1, 2, 3, 4, these four crystals will cover the total atom. So one atom contributes 1/4 to a particular crystal. That's why their contribution is 1/4. So since there are four atoms like this, so it will be 4 into 1/4, that is 1. So from those corner atoms, the contribution is 1. And from those atoms that are present at the middle of the sides, we need, suppose this is present here. So 1 is here, 2 is here. So 1, 2. So there will be two crystals needed. So the contribution is half per crystal. That's why there is a half. So half, 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 half. So there are four such atoms. So 4 into half is 2. So these 2 corresponds to these 4 atoms. And then if you talk about the remaining one is the central one. So this central one is already enclosed inside. So this corresponds to 1. So there are total 8 atoms per unit cell. So is this clear
Okay.
to you?
Yes, sir. Okay.
Okay.
Thank you, sir. Yes.
So we will move to the seventh question. The question says, calculate the lattice parameter of gallium arse- gallium arsenide when the radius of gallium is 1.22 angstrom and of arsenic is 1.25 angstrom, and consider gallium arsenide is zinc blende type crystal structure. So we just discussed in previous questions. So in case of zinc blende type structure, it is like diamond structure, but this is one corresponds to zinc and another corresponds to sulfur. So similarly here, one atom corresponds to one type of crystal corresponds to gallium and another corresponds to arsenic. So we will need to calculate the density, and the options are option A 5.635 angstrom, option B 5.704 angstrom, option C 5.774 angstrom, and option D 4.940 angstrom. So I'll give you a few minutes to try this question, and then we will discuss.
Okay. And actually, this is a zinc blend structure. Huh? In this zinc blend
Yes.
structure,
So
the atomic radius is equal to root 3a by 8. Is it correct, sir?
no, not like that.
No.
So if you see this previous explanation, so these 4 that I had completely filled, these closed circles corresponds to a particular type, and the remaining corresponds to another particular type. So that's why if you see, so these 4 corresponds to these 4, and the remaining 4 corresponds to another atom. So if you consider about the zinc blend structure, that is zinc sulfide structure, there are 8 atoms in unit cell, and out of those 8 atoms, 4 is of zinc and 4 is of sulfur. So that's why if you see the So if you see this, let me draw it again. So this is the structure that we discussed now. One is present here, one is present here, one is here, one is here. Then at the corners, then also here, 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 and another is present here. If you see these four, so this corresponds to sulfur and this corresponds to zinc. And so if you take this particular, so this is the body diagonal, and the body diagonal is root 3a, and this root 3a. So there are two atoms of sulfur and one atom zinc here, half and half. So this is R, this is 2R, this is R of zinc, this is 2R of sulfur, this is 2R of zinc, this is 2R of sulfur, and this is R of zinc. So if you see, there will be 4 R's of sulfur and 4 R's of zinc. This will be 2R sulfur plus 2R sulfur plus 2R zinc plus R zinc plus R zinc. So it will be 4R of sulfur plus 4R of zinc. That's why A will be 4 into R sulfur plus R zinc divided by root 3. So the same thing was also given here. So if you see in this question, if you see the same thing was given, A equals to 4
Yeah.
R zinc plus R sulfur divided root 3. So since this is the
Yes,
zinc
sir.
blend
Yes.
structure in the question, so we will use this same formula. And if you use the formula, it will be 4 into 1.22 plus 1.25.
Oh, probably 5.70, sir. 5.65.
The correct option is 5.704. Yes, the correct option is
Yeah,
option
70.
B. So it will be 4 into
704.
1.22 plus 1.25 divided by root 3. It is 5.704 angstrom. So this is the correct answer, and the option is 5.704 angstrom. That is option B.
Yeah.
So I
Actually,
hope
I
this is
took 8, sir, directly. I
no,
took
not
8,
8.
so that is wrong. Yes, sir.
No, not 8, because out of those 8 radius, 4 are of zinc and 4 are of sulfur. That's why
Sulfur.
they will contribute 4. So 4 number, because here if you see in chlorine, in sodium chloride also there was same thing. Na? In sodium
Yeah.
chloride, there was
2Cl2.
4 Na and 4 Cl, but the difference is they are displaced by one half of the side, but here it is displaced by 1/4 of the body diagonal. That's why in that case it was 4R is equal to A, but here it is not. It is 4R. It is 4R plus 4R equals to root 3A. That is
Okay.
the main difference between the sodium chloride and the zinc blend structure.
Yes, sir.
So if you talk about some other atoms that have also zinc sulfide structure, so copper chloride is one of them. Then indium, uh, INSB means indium, and then is cadmium sulfide also. It has also the zinc blend structure. So cadmium, the position of cadmium will correspond to the position of zinc, and the sulfur position will correspond to the position of the sulfur that are present. So these, so we'll move to the next question, that is question number 8. The question says the atomic fraction of tin present in bronze which is an FCC crystal with a density of 7,717 kg per meter cube and a lattice parameter of 903 Armstrong will be what? A, option 0.01, option B 0.07, option C 0.10, and option D 3.8. So if you see, the question says what is the atomic fraction of tin in bronze? So bronze, if you see, in bronze there is copper and there is tin. So the atomic weight of copper is 63.54 mu and the atomic weight of tin is 118.7 mu. And the density of bronze is given 7717 kg per meter cube and the lattice parameter A is 3.903 Armstrong. So we need to find out the packing fraction. Packing fraction means the total volume out of which there are some empty spaces also and there are some atoms present. So the volume of the atoms that are present inside the cube and the total volume of the cube will give the packing fraction, that is the ratio of acquired volume by total volume. So that will be the correct answer. So I will give you a few minutes to try this question and then we will discuss what will be the process to solve this question and how we will proceed to this question.
Okay.
So it is a very interesting question also. So we will be approaching in some different ways. So I will encourage you to try this question. Otherwise, I will discuss.
So please explain, sir.
Sorry.
Please explain.
Yes, I will definitely explain. So that's why I am here. That's why I also encourage in every interaction session. In the previous two interaction session, I was telling again and again, please join in this interaction because only when you join the interaction session, there will be discussions. Otherwise, I will come and solve the questions and I will go. So
Yeah, yes, sir.
here, if you see, in order to find the atomic packing fraction, we need to find out how many number of atoms of copper is present and how many number of atoms of tin is present. That is their contributions. So we know in case of FCC structure, the total number of atoms per unit cell is what?
Four.
4. So out of this 4,
Yes, sir.
what is the contribution of copper and what is the contribution of tin? So according to their contribution, we will be taking their mass. Because since in the suppose there are 4 sodium and 4 chlorine, that's why we are taking 4 into mass of sodium plus 4 into mass of chlorine. But since here
Yes.
some particular contributions are not given, so we will calculate the exact contribution, how they contribute to the bronze alloy, where there is some part is tin and some part is copper. So how will approach? So there are two unknowns here. One is the contribution of copper, another is the contribution of tin. But out of those 4 unknowns, we know one of them relation is, suppose copper is X, and tin is Y. So what will be X plus Y? What will be X plus Y?
X plus Y means total 4.
So X plus Y will be 4. Absolutely. So this is the one equation. So we need another equation. If there are two equations and two unknowns, we can easily calculate what will be the value of X and what will be the value of Y. So what will be the other equation? How we can get the other equation? The other equation we can get from this density, because density is mass by volume, and we know
Yeah.
the volume is A cube and A is given 3.903 angstrom, and mass we need to find out. So mass will be depending upon the contributions. So density will be mass by volume, that is mass of copper plus mass of tin by volume A cube. So since the contribution is X for copper and contribution is Y for tin, so we will multiply the mass of copper with X. The mass of copper is given 63.54 astronomical unit, atomic mass unit, plus Y into mass of tin is 118.7, and since A mu is given, we will multiply 1.66 into 10 to the power minus 27 divided by 3.903 into 10 to the power minus 10 cube. If you look here, this is in kg, 1.66 in 10 to the minus 27 kg. That's why we converted it into meter cube. So the density is given in the meter cube, kg per meter cube, which is 7,717 kg per meter cube. So this is another option. Sorry, this is another equation. So this is equation number 2. This is equation number 1. So if you simplify it, the equation number 2, you will get 63.54x plus 63.54y is equals to 254.16. This will be equation number 2. And if you solve these two equations,
After simplification, we get this one, sir.
yes. So after simplification, sorry, not after simplification. 1 minute. Sorry, I did the wrong thing. Very so. So if you simplify equation 2, so this is not correct.
Yeah. I
So
actually
equation
118.
2, so this is, if you multiply 63.54 with equation 1, you will get this equation. So if you simplify the equation 2, you will get 63.54x plus 118.7y equals to 276.40. This is equation 2, because it is 63.54x and 118.7y. So this is equation 2. And equation 1, if you multiply 63.54, you'll get 63.54x plus 63.54y equals to 254.16. So this is equation 3. So you got these equations, and if you calculate, you will get y equals to 0.4.
Okay.
You got it? Y equals to
Okay, sir.
0.4. So if you see, what is the question? The atomic fraction of tin in bronze. So in bronze, there are total 4 atoms, out of which 0.4 contributions come from tin, because we In the problem, we have taken the contribution from tin is Y and the contribution for copper is X. So the atomic fraction will be the atomic fraction of tin is 0.4 by 4, that is 0.1. So out of the 4 atoms, 0.1 contributions come from tin and the remaining 3.6 contributions come from copper. So the correct option will be option C, that is 0.10. So is this clear to you?
Yes, sir.
Okay, so we will proceed to ask the next question. Question number 9 says, find the Miller indices of a plane that makes an intercept of 1 unit on the A axis and 2 units on the B axis and is parallel to C axis. The options are option A 120, 210, 021 or 201. So these are the 4 options. So this question is based on calculation of Miller indices. We have solved a few questions in the previous interaction session also. Also in the previous interaction session, I had already mentioned how we will calculate the Miller indices. So I'll give you a few minutes to write this question and then I will discuss.
Is it 210, sir?
Absolutely correct. So the correct option will be option B 210. So how we will calculate? So if you see,
Uh,
generally we take x by x intercept, y by y intercept, z by z intercept. So here xyz means a b c. So it will be a by x intercept. So x intercept is 1, is not it? Then on the b axis it is 2, so it will be b by 2, and then in the c axis it is parallel to c. So since the plane is parallel to c, so it has no intersect at z axis. So since it has no intersect at z axis, so it will be c by infinite, is not it? So if you reduce it, sorry, if you divide by those lattice parameters, so it will be a by a, b by 2b, and c by infinite as into c. It will be 1, 1 by 2, and 1 by infinity is 0. But we know Miller indices are integers, they can't be rational number. So we will multiply 2 with all these numbers. So if you multiply 2, it will be 2, 1, 0. So the correct option will be option B 2, 1, 0. Okay, so is this clear to you? We will move to ask the next question then.
yes, sir. Next question.
Okay, so we'll move to the question number 10. The question 10 says, find the Miller indices of a plane that makes intercepts on the 3 crystallographic axes which have dimensions 2 angstrom, 3 angstrom, and 6 angstrom in a tetragonal crystal respectively. Consider A, B, C are the primitive vectors of the unit cell and the ratio of the primitive vectors for a tetragonal crystal is C by A equals to 1.5 angstrom and A equals to 2 angstrom. The options are option A 436, option B 463, option C 643, and option D 346. So how we will calculate this? So I will request you to try this question, and after a few minutes we will discuss.
Okay, sir.
Here in the previous question, the previous question it was, so all the values were A, B, C. So but here the relationship is not like that. There is a proper relation between A, B, and C. So C by A is 1.5 Armstrong and A is 2 Armstrong. So according to this, we will be calculating. So you just write this question and then I will discuss how we will proceed.
Sir, 6 to. Okay.
Sorry, 6-2 means
6 to 3 I got, but there is 6 for 3.
so I will calculate 1 minute. So
Sir, is it a 643, sir?
yes, the correct answer is 643. That is option C.
Yeah.
So how did you calculate?
So I took that XYZ, sir, means ABC, A by X
Yes.
intersection, B by Y intersect, that is a 3.
Hmm.
Next, C by C, yes, C means 6.
Hmm.
C is equal to, I got 3.
Yes. So now C by A is 1.5 given.
Next, A is equal to 2, so 2 by 2.
Hmm.
Next, B is equal, actually, I have some doubt in B.
So in the previous question, if you see, in the A axis it was 2 units of A, B axis and C axis. But here it is the value is given 2 Armstrong, 3 Armstrong and 6 Armstrong. We have to convert it in terms of A. So if you see the intercepts are, generally if you see the intercepts will be PA, QB and RC. And those intercepts are 2, 3 and 6. So we know A and B are equal in case of tetragonal. A and B are equal. So it will be 2 into, sorry, 2 into P.
Again
Sorry, it
2B.
is not 2. It is A into P, then A
A,
into Q, and then 1.5 A into R because C is 1.5 A. So it is Q A into P, A into Q, and 1.5 A into R. So then PQR will be 236, 2 by A, 3 by A, 6 by 1.5 A. So it will be 2 by A, 3 by A, 6 by 3 by 2. It will be 12 by 3, that is 4 by A. then we need to take their reciprocals. So it will be, so 1 by P, 1 by Q, and 1 by R will be A by 2, A by 3,
Yeah.
A by 4.
Yeah,
And since A is 2, A is 2 angstrom, so 1 by P, 1 by Q, 1 by R will be 2 by 2, 2 by 3, 2 by 4, will be 1, 2 by 3, 1 by 2. So we will reduce it to integers. So if you multiply 6, then 6 into 2 by 3 will be 4. If we multiply 6 here, 6 into 6 into 2 by 3, 4. Then 6 into 1 by 2, 3. So 643 is the
yes.
correct
Oh,
combination of Miller indices. So the option will be option C, that is 6, 4, 3. So this is clear to you?
yes, sir.
Okay, so today we will conclude the interaction session here. And in
Okay,
the
sir.
next session, we will discuss a few more problems that will be based on the week 4 of the interaction session. So
Based
if
on, sir?
if
Based on?
you, sorry, based on week 4,
Uh,
the fourth week, which will cover the
okay, sir.
electrical properties of matter, I think. So the next Tuesday, so generally what happens, I take the interaction session every Tuesday, but today due to some unavoidable circumstances, had to reschedule it to today, that is Monday,
Okay.
7 to 9 p.m. So I request you, so I encourage you and I request everyone to please join this interaction session so that we will be discussing a few more problems. Or do you have any, or if you have any doubt regarding to the course or any doubts regarding to the course, then you can also ask me in this interaction session. So that's it from my side. Have a great day.
Okay, sir. Sir, can
Yes.
sir, this video will be uploaded on which date, sir?
Yes. So uh, this video will, by tomorrow 12 p.m. you will be finding the video. I will be updating the link of the video in the weekly sheet that you must have been provided. Na? There is a sheet where the links of the videos are already present there.
There only two videos, sir. Sir, oh, actually, how many classes like this conducted, sir, up to now?
So
Three or
only
four?
two classes I have taken. Since
Okay.
this is third week, so this is the third interaction session. So this recording of this third session I'll be uploading tomorrow itself. So
Okay.
after tomorrow 12 p.m. you can access the link and you can see the recording of this session.
Okay,
So
sir.
with this,
Sir,
I need, yes,
I have one doubt. Actually, in the main examination, only the multiple choice questions will come or descriptive, sir?
and actually all these queries you can ask in the discussion forums. I am only
Okay.
associated with the interaction session. So any technical doubts like the
Okay.
conceptual questions you can also ask. But all these uh, uh, queries related to the examination pattern and all, you can anyway ask the other coordinators that are present in the course, and they can
Okay.
be available in the discussion forum. So you can mail in the discussion forum. So there is a discussion forum now, question answer forum. You need to sign in there through your Gmail ID, and then you can post your queries there. And so there are dedicated persons there, so and they will attend those queries and they will answer it.
Okay, sir. Sir, next to one doubt. Actually, for attending this class, same passcode, sir. Next week also.
Sorry?
Uh, for the next class, to attend the same passcode and the same user ID, no, sir.
Exactly. This
Okay,
is
because
valid for the
in the
entire duration of the course.
last class it asks some passcode and user ID. I can't attend this class, sir. So that I'm
Okay, no. I today in the morning I just saw your query. I think you had posted in the interaction in the discussion forum. That's why I had mailed you the passcode and the ID.
so that won't I attend today, sir. Otherwise I can't because it's not
No,
accepting.